Welcome back. Today's topic is characteristics of digital protection. In the last lecture, we have discussed about the classification of relays, the evolution of relays. We have seen that so far we have got 5 generations of relays, starting with electromechanical relays, which started somewhere in 1900. And next, in 1960s, we have got the static relays, followed by microprocessor-based relays, and then followed by PC-based relays, which we call them as numerical relays. And now the modern generation, i.e. intelligent electronic devices. And then we had this features of digital relays. Digital relays are all those relays which do convert these analog signals to digital signals and then process them for sensing any abnormality. So, as a continuation of this one, we will discuss about the characteristics of the digital protection. So I hope that by the end of this video lecture, you will be able to describe the operational characteristics of digital protection. So I'll be discussing only about this one, the different benefits. We'll have a discussion on this one in the class, but let me give you a simple glimpse about what advantage we do have with this digital protection. So first of all, the list of this, the important list, the only important things. The first thing is we can rely upon this digital protection. See, benefits of digital protection can be broadly classified into 5 main areas. This is what I have written there. So the first thing is reliability. Second thing is flexibility. And the third one is operational performance and cost benefit considerations. And finally, any other features which we do have that we will discuss in detail. So the first one is about reliability. How reliable are these digital relays? See, the biggest advantage of having this digital relays is that they can monitor themselves. So let's take a quick example of a microprocessor relay or a PC, advanced microprocessor relay, or what we call as PC-based relay, right? So any data, analog data which you are measuring there in your power system, that can be transformed into digital data, sent over distance to your processing device. And these devices, basically, they will sense the things and they will, if at all there is any abnormality, they will give you information. Based upon that, your circuit breakers will be tripping up. So these digital relays, they are basically designed to regularly monitor themselves. This is the biggest advantage which we do have with this digital relays. And their programming can be extended. As already mentioned, you can take a computer-based thing. A computer-based thing basically can do multi-functions simultaneously, isn't it? It is just like a human brain, more than a human brain when it is assigned tasks. Maybe it cannot independently think just like us, but when it is assigned particular tasks, it is multitasking. It can perform multitasking. Similarly, the digital relays also, the function of them can be extended by programming the relay to monitor its peripherals. And if the relays basically, if they do have this concept of self-monitoring, then automatically what happens is that the reliability is going to increase every time. It is just like a self-learning mechanism. So the reliability is going to increase. And one more thing is that the digital relays can be improved further by building a degree of redundancy into the hardware and software design and using different operating principles within the same relay. And with this artificial intelligence coming to picture, you can see the more you learn, the more reliable you are. So this advantage is offered by the digital relays, which was not possible with the old generation relays. And next was the flexibility. The PC-based relays or the microprocessor relays, they were very, very flexible when compared to the conventional relays. The first and foremost thing which I told you that they can perform multiple functions simultaneously. And the biggest advantage is their characteristics can be changed. because they are highly programmable. If you change a program, then automatically the function of that is going to change. It is just about programming. You can vary the level. Very simple. Just to write a program, you can vary the pickup value. You can change the threshold values, or you can change the conversion things, or you can go with some other frequency technique measurement. So it's just all about a good software programmer who can write an efficient program so that the application can be changed completely. So this is just like relay being more flexible for you. Earlier generation relays, they didn't have this concept of programming. And if you carefully see, for a variety of functions, you can use a single hardware. So just your PC is fixed. You can install so many number of softwares in that. So let us suppose if you do have multiple functions and you do require multiple softwares, you can use a computer, right? So you can install so many programs, so you can use softwares in that, and with that you can perform multiple functions also. So single hardware, multiple softwares, multiple features, and everything is programmable. So that is flexibility which is offered by this digital LS. And as mentioned, they can be equipped with multiple characteristics. And if you want to change anything in the middle also, that is also possible, isn't it? So any revisions, any modifications required in the operating conditions of the system, let us suppose normally you want to sense a temperature. If anything is beyond 30 degrees centigrade, you want to immediately trigger the abnormality, trigger the fault. Then let us suppose if the temperatures have become too hot on this planet. So immediately you want to change the 30 degrees centigrade to 32 degrees centigrade. That you can immediately program it. And you can automatically adjust the level. So that is the advantage which is offered by the digital release. Any revisions or modifications that can be done easily with this release. So without any changing of hardware structure, just a good program, if you can write, then automatically you can do everything. So that is a flexibility which is offered by this digital release. The next is operational performance. Many research studies, this is not done by me, many researchers have clearly stated that digital release, they perform much better when compared to the conventional release. Maybe because of the multiple functions they do and because of the revisions and modifications which they can incorporate very easily. And in particular, they are found out to be very, very better when compared to the conventional relays in UHV, EHV lines. You know that very high voltage lines in power systems. We will be having too many number of UHV, UHV lines you might be seeing across the country. So for the protection of these lines, digital relays are very, very suitable because these lines will be operated at very high voltage. They'll be running over very long distances. So it's better if you do employ sensors everywhere, measure the parameters, convert them into digital, send to some remote areas, check, again send it back to the circuit breakers for tripping. So it is far better than having an electromechanical device always connected there to the main lines, isn't it? So any EHV, UHV transmission lines, series shunt compensated lines, multi-ended circuits, for all of these things, it was found that digital relays, they offer much more benefits when compared to the electromechanical and static relays. And the most important thing in the operation, the very clear distinction between the earlier generation relays and the digital relays is that, see, memory action and complex shaping of operational characteristics. You can build as much complex as you can. It all depends upon you being a good programmer. So the more good programming you have skills, then automatically you can create more complexity in the circuit. So complex problems can be easily solved with this digital relays. And the biggest advantage, they do have memory also. So anything you want, you can create it. And next is cost benefit considerations. Yeah, this is a debatable question. When started in 1900s, electromechanical relays were also used to be very costly. But later on, over the 50 or 60 years, the electromechanical relays cost has been reduced because of huge production. And next came the solid state relays. Earlier they were very unreliable, but later on, because of the solid state technology, semiconductor technology, they also became cheap. microprocessor relays may be costlier, but with the mass production, their process nowadays, even microprocessors also, they are costing very less, right? So earlier they used to be costly, but nowadays the cost is reducing. And it's not just the microprocessor or microcontroller or advanced computer which costs you more. It's about the software, because when you're looking into the cost of the relay, for electromechanical relay you will directly buy a relay, isn't it? But whereas for a digital relay, you do need a hardware, and also you do need a software also. The hardware costs are very nowadays they have decreased a lot because of the mass production. Very high processing processors are also available now. Maybe the higher you go with the processing speed, the cost will increase. But the biggest cost is with the softwares. Specialized softwares do cost you more. But when compared to the electromechanical relays, cost benefit ratio is nowadays it is decreasing. Cost to benefit means, let us suppose if you spend 1 rupee, how many benefits you are getting, or for a particular benefit how much cost you are spending. See, for a electromechanical relay the cost of unit is less, but the benefit is only one. So it is just like you having electromechanical relay for 100 rupees, and the benefits you will be getting is only one. Whereas a digital relay may cost you 1000 rupees, but may offer you 50 applications. So if you carefully see, the cost is 10 times. But if you see cost per benefits, it is 100 by 1, it is 100. Whereas this one, it is 1000 by 50. Cost per benefit, it is 20. Even though the individual cost is high, but cost per benefit, it is very low with the advancement in the digital relays. And in particular, since the softwares are costly, your cost is a little bit higher. The cost of hardware is very simple, because the advancements in microelectronic technology, these have reduced the cost of the hardware so much. And see, yeah, situations exist where the cost of software for commercially developed equipment exceeds that of the hardware by a large magnitude. That I will also agree, but you can find so many freewares also available which you can use if you can have. One of the most important things is it is not the hardware and software, it's a user who has good knowledge in this application. And on the other hand, high volume digital relays, particularly the over-country relays, which are very simpler, they are very relatively cheap because they have been in the picture for the past 25 years. So many developments. So digital over-country relays, now they are very cheap now, because there is a huge production of digital over-country relays. Specialized relays, they are a little bit costlier now. Maybe in the near future the cost may reduce. So if you do have very high sales volume, then automatically the costs will come down, right? So overall what I can say is nothing but, when compared to the electromechanical relays, the cost may be higher, but the cost per benefit ratio is low when compared to the electromechanical relays. And lastly, the other features. As already mentioned, ear relays can be programmed to provide post-fault analysis. So whatever the transient conditions which you observe after the faults, so ear relays can be programmed to provide your analysis. So multiple data can be stored and processed for future purposes also. That is the biggest advantage of your numerical relays or digital relays. Electromechanical relay, once it senses, just it gives a signal to trip it off and it is done. The job is done. But whereas here, you can continuously monitor the thing. You can store the data every time. You can use it for future purposes also. So the biggest advantage of that, see, I have mentioned, digital equipment monitoring both voltage and current can be programmed to compute the distance to a fault immediately after the occurrence of fault. This is one big thing which is advantageous for several people, several engineers who are working in the fields. So if you can know the distance of the fault, where it is happening, then you can immediately alert the people there, so that you can immediately check there. So this type of applications, this type of advantage you do have with the digital relays. And reduction fault clearance times. This is resulting in reduction in visual evidence of the faults. Right. So with these advantages which are offered by the digital relays are nowadays they are more and more in usage when compared to the conventional relays. So the conclusion is that they offer many benefits when compared to the older generation relays in terms of reliability, flexibility, performance, and cost. So I hope that now you are able to describe the operational characteristics of digital protection, and you can explain very clearly why digital relays are nowadays they are gaining importance. And see, these are the lecture level practice questions. The first thing is a generalized question. Describe the characteristics of digital protection. The second thing is the more significant question, that more see, why are digital relays preferred over conventional relays in distance protection? That you need to answer. Very more specific question. So you think, search the internet, get the answer for that. We will have a discussion in the class. Okay. So these are the first one is a textbook which I have referred to. These two, the bottom two are the references. You can go through them. So we'll meet in the class for further discussion. Thank you.